Now I have the pleasure to introduce the last speaker of today. He will talk about energy and CO2 impact of eco-design regulation for fans on the European market. We are talking about Claus Händel. He is a graduate engineer from the University of Stuttgart. He worked for over 30 years in the ventilation and air conditioning business. Since 10 years, he is the technical secretary of the European Ventilation Industry Association. And I've met and we have seen each other in German and European legislation on building technology in CEN and DIN standardization. Claus Händel, you have the floor.
Good afternoon, ladies and gentlemen. My name is Claus Händel from European Ventilation Industry Association, and I'm glad to present something this afternoon on the Motor Summit on Eco-Design Regulation of Fans. First of all, I introduce myself. I'm Claus Händel, and I'm working for EVIA and for Fachverband Gebäudeklima since almost 20 years in ventilation and fan business. We made an estimation of market. We made a market survey on fans placed on the market in the EU, and considering different types and different fan efficiencies. And we made a calculation on the expected electrical power, CO2 and energy consumption savings. I would like also to present a short outlook how we like to estimate the market within the next 5 years. First of all, let me say something about EVIA. EVIA was founded 10 years ago almost. We have 5 working groups dealing with residential, non-residential, fans, connectivity, and some other horizontal issue, meaning all ventilation aspects within a building within Europe. And we have also many national associations, and we try to harmonize national views in a national association liaison group. The basis for our market estimation for fans was the following. We considered data placed on the market in EU 28, that means including UK. We collected fans from different manufacturers, and we approximately estimate a market share of 33% of these manufacturers in the European market for different sizes and for different types. The results have been estimated, let me say, extended to the whole market size we estimate in Europe. Typical power savings delivered for each fan size groups has been questioned, and we considered roughly 4,000 hours operating hours to determine an energy consumption impact and an estimated savings. For the CO2 savings, we used electrical energy, that means 460 gram CO2 per kilowatt hours electricity. And sometimes we cannot exclude exports outside the EU. That means products that have been delivered to manufacturers but placed on the market outside the EU. So there will always be a stock of non-compliant products, including exports and spare parts within the market. The savings are estimated on base of best efficiency point. That seemed to be quite optimistic. But we did not consider variable speed drive because currently most of the applications currently have variable speed drives. And we do not consider very large fans above more or less 22 kilowatts and no jet fans. Our first estimation was published 2 years ago, and we tried to, let me say, upgrade this with this study and this presentation. For the upcoming limits, we expect eco-design regulation revision since almost 2 or 3 years. This was the last presented minimum requirements for the next revisions of the eco-design regulation. We're using this for our estimations, but industry is awaiting very hard on the new regulation because we need these clarifications, and we need a publication of this regulation. It does not help whether it's been blocked since almost 3 years. This is, let me say, an estimation on the market transformation. We collected data as set up until 2018. We had a split there between fan regulation limits 2013 and 2015. So you see here the red and the orange colored, which are compliant fans not with the Ecodesign regulation in red, and orange with the tier 1 of the regulation. And then we have a green colored, which is identifying the compliant fan with the fan regulation 2015. And then starting in 2018, we also questioned fans expected to be compliant with the next regulation, and this is colored in blue. And the steep, let me say, growth of these fans maybe is based on the aspect that we do not question these compliant fans before 2080, so there might be a more flat rate on that topic starting earlier. So, but this is uncertainty of the questionnaire. Here are some results of the typical data size. We questioned axial fans, we questioned radial fans and others, and we had 5 groups of different sizes. And some manufacturers could not deliver data for each group or for each fan type, so it's somehow a mixture of all that. But we tried to analyze at a basic stock and a basic estimation, and this might shift a little bit the average values. But you see by pieces, the right chart, it is most of the pieces are smaller fans below 100. Below 375 or below 750 watts, and we have a smaller amount of bigger fans. So that is quite, let me say, a guidance which took the lead to also include smaller fans. But if we do the same estimation and we weight this with an average power estimated for each fan groups, we see that the biggest impact is on energy side is given within the group of 3 to 11 kilowatt electrical capacity, and these fans play the biggest impact on the energy consumption of the estimated market share. So there's also some shifts in between the average, but this gives a good information about the main impact of the fan sizes. If we calculate average savings of all pieces, so we weighted on pieces, we weighted on capacities, and this slide will show you the estimated impact of savings, which are including a starting point of 2012, where we estimated to 0 savings. We estimated a market share on compliant and non-compliant products, and from then on, we get savings from each year placed on the market fans. That means it is an addition of fans placed each year. And you see here the blue line is showing the energy savings or the power savings in each year by piece when placing on the market. And we have the average rate on the blue line, and we have the each year rate for the orange line. And we see there that the more efficient the fans seem to be, that means starting 2018, the average energy consumption savings are higher. But if we calculate on all average of all, summarizing all years, we have still a stable growth of energy savings for fans placed on the market. If we accumulate by energy consumption and capacity for all fans, and also the starting point is 2012, that means 0 savings 2012, and we accumulate the new placed on the market fans each year, weighted by the capacity and weighted by the size, and weighted by pieces. So you get, let me say, the whole savings achieved since Ecodesign regulation is valid, saying 2012, and then we get up to 140 terawatt hours already saved, that each year placed on the market fans add to the next year and add to the next year. So we get a summarized energy consumption which is achieved each year. And if we consider the electrical power, we see that roughly starting the last 8 years, we achieved 12 gigawatt hours savings electrical in each year. That means roughly 10 big power plants which have been avoided by placing on the market more efficient fans. If we combine this and look at the estimation what we might have in 2020 and CO2 savings, we might achieve roughly 12 megatons of CO2 within the last 8 years, accumulated from starting point 2012. Let me give you a short outlook on the market, what we expect to 2025. The basic is that the regulation will come soon. We expect the regulation to come soon, but if the regulation will not come, I think this estimation will be not realistic, because then the market will also keep stable what we currently have. So we need the pressure of the new regulation which comes up hopefully within the next year to push the market, to push the manufacturer to realize this huge savings what we expect up to 2025, which is the, let me say, shift to compliant fans with the new regulation, the blue, and reducing the non-compliant fans by a small amount. Some manufacturers are challenging the impact of fan regulation because fan savings might be considered within other Ecodesign regulated products. So by estimation in 2017, we found out that only roughly 20% of the fans are implemented in other products. Our new questionnaire shows a bit more, maybe new Ecodesign regulation have coming into force, that nearly 50% of all fan products are somehow placed with other Ecodesign components on the market, but still another 50% are placed on the market with no other Ecodesign regulation valid. So our estimation will somehow be double counted, because it can happen that the fan savings are already counted within the boiler or the chiller or the boiler or the cooling tower or the ventilation unit. So we need to be aware that the energy savings I show you now might be 50% too high, because they are considered somehow in other products. Fan changing is efficient. It can be very efficient. It can be efficient by two means. It can be a win-win situation for all. This chart is showing fan changes in different applications, in air handling units, in cooling towers, in chillers, in other ventilation means. And this shows, I would say in this case, bigger fans in the average size, roughly about above 5 kilowatts. But even this change by full cost calculation shows that we get a win-win situation for all. It produces negative CO2 avoiding cost. That means it saves energy, it saves cost, and is also a benefit for all operators and also for the manufacturers, because we have a double effect of all these savings by cost and by energy and by CO2. And depending on the size, or let me say in the time period we consider for payback, 5, 10 or 15 years, it shows that there is an impact for sure, but it will stay negative. So fan change in existing buildings, in existing plants might be very cost effective. So a short summary on all that. Ecodesign regulation for fans is an important driver for energy efficiency. The impact is significant. We cannot avoid it. Savings in electrical energy calculated since almost 2012. It will be roughly 12 gigawatt of electrical power, approximately 1% of EU27 capacity. We saved 150,000 tons electrical energies, roughly today 20 terawatt hours per year, and this is summarized over the last 8 years. This is approximately 0.7% of total energy consumption, and this leads to 12 megatons CO2 revision, 12 megatons CO2 reduction. So the revised fan regulation is urgently needed for clarification, for definitions, and also for the market transformation to more efficient products and components. And investment for fans lead to an efficient way and negative CO2 investment cost. Thank you very much for this opportunity to speak about this issue, and in case of question, please contact us. Thank you very much.
Thank you, Claus Händel. Interesting summary on the status of European market development regulation for fans. Yes, here's Claus Händel. Hello. How are you?
Hello, you can hear me
Yes,
quite good, quite
I
well.
see you,
Thank you
and
very
I
much.
can see a very nice fan unit in your back.
A ventilation unit, yes.
Yes. Are you sitting in a laboratory, or is this just a picture and you're talking from home?
That's just a fake. I'm talking from office, and this is a fake in the background.
Not a fake, it's a picture of a real thing.
Picture, yeah.
Thank you for your interesting presentation. I want to start with the discussion, why are the revisions of the fan regulation going so slow? You have heard or seen maybe Ronald Piers de Ravschot from the DG Energy, and he talks about this process, which is relatively complicated until all parties agree. On one side, the industry, on the other side, the environmental group, and in the middle, the government. And then he goes back with the impact analysis. Do you think somebody is slowing down the process, or it's just it takes so much time to get there?
Let's say, for speaking as for fan industry, it's not understandable why it takes so long time on that specific product. Maybe you have a similar situation with the motor regulation itself, but I would say with the fans and all components, it's always, to be realistic, a topic where the components or subsystems might be considered in a further final product.
Yeah.
And this is, I think, one of the biggest debates we have within other industry parties. And I would say, as my estimation shows, the fan itself is a key efficiency element of many other products, and we should not let me say, debate whether components are value to be regulated or not. I think it is a key component for energy efficiency, and we have to speed up. And I would say it's not the only reason, because in the Commission itself, there might be different, let me say, weighting factors on a fan, which seems to be not very attractive for the public relation. But anyhow, I can not understand, finally speaking, why fans are waiting so long, because it is already finished for our understanding since more than 2 years.
Yeah, thank you. Are you also considering in your efficiency calculations the use of variable speed drives?
Currently not. We are focusing on the data we have on best efficiency point. We could not consider variable speed drive because this is one of the key issues we are debating, and I think tomorrow we will hear more about all that topics. We have very different approaches of variable speed drive. In ventilation unit, like in the background, we might have very different ones from a cooling tower. We might have very different ones from an industrial process, and it's difficult for us currently to determine the savings for a variable speed drive. We are working on that, but anyhow, it is not in our calculation.
It's not the use of a variable frequency drive to modulate the flow, but the difficulty is to agree on some standardization values from standards that could be then used in the minimum energy performance regulation. That's the difficulty, right?
Exactly. Because we have so many applications and so many uses, and we cannot really focus on one or two, let me say, part load curves or whatever we determine that. We have to be fully open on that topic.
Yeah. Now, the current fan regulation in Europe, the 327 from 2011, is still in force.
Yep.
Question came in, do the motor regulations from 2019, the number 1781, apply also for fans, now regulated by an older regulation?
I think that can happen depending whether these fans are, let me say, part of, or let me say, whether these are part of the fan itself, or will we place on the market a separate motor and combine it with the fan. So it is an issue whether a fan and a motor are a unique component, or a motor and a fan can be combined as two separate components.
Yes. Now, I want to ask a final question, which is for myself. And I apologize because it's a very nasty question. I've asked this question also at stakeholder meetings in Brussels. We have 4 or 5 different types of fans. You know better than I do. And we give target value for each one of them, even for the bad ones, which are never able to reach the higher level. Shouldn't we go, let's say, not tomorrow, but in a 5-year, 10-year cycle, and to eliminate certain technologies which cannot reach higher values? And we wouldn't eliminate by saying you are not allowed to buy a forward curved fan anymore, but we require efficiencies that you can only reach, for instance, with a backward curved fan. Wouldn't that be necessary? Because we are now having a developed market. It's not like 10 years ago where nobody talked about efficiencies of fans. Now we know what technology can achieve, and we know what that means for technology. Shouldn't we start to limit the types of fans that are capable of reaching high efficiencies? Question to you.
Yeah, I would say answer quite rather simple. If we would have space and options like you see in my background like that, where you can design a fan according its needs, I would say I would agree on that. And we have this more or less in the ventilation regulation, or the fans used in the ventilation regulation. But there are other needs, and I would say typical, our products last 20 years or longer. We have limited spaces in given areas. We have requirements on acoustics, and even I would say a cross-flow fan where the efficiency might be really low, and which is from the performance, from the efficiency, quite weak. But there also are applications where he performs great, and this is the application we see. So up to current, I see now to current timing, we need to keep the market open for different fan designs.
Okay, my last question, the comment or question. In the age of a pandemic called COVID, clean indoor air quality, higher ventilation rates, aerosols becomes a big issue. Is your industry profiting?
Yes, ventilation, I would say, is on the topic of everybody, and whether it was neglected over the years. So I think ventilation is one of the key issues where we have to design our future things. We are profiting directly when we are talking about air cleaning devices, filter fan units which can be, let me say, directly transferred to a school pupil room or whatever. So our industry, especially fan industry, because we need air movement on that topic, is profiting from that. But I do not like to profit from a COVID-19 pandemic, because ventilation already is important, but we neglect it over decades, the deep need of ventilation in our modern buildings.
Okay. Thank you, Claus Händel. Thank you for your presentation. Thank you for your insights. We have concluded our 4 sessions of the first day of the Motor Summit 2020. I'm happy to hand over to Rolf Thieben for the final remarks. Please, Rolf.